We are now ready to use this drill press, the machined MDF that we need for our first project. Before we do this, however, we need to cover some important topics before we actually operate the drill press. The topic we're going to start with is involving the safe operational use of the machine. To usually find that, you look in the original owner's manual, a sample of which we have here, which has all of the safety procedures that need to be followed. This is one page of the 2 or 3 pages that typically come with a machine involving its safe operation. They are frequently boilerplate safety directions covering pretty much everything that you could possibly think of on a drill press, and sometimes even saws and milling machines. But they will cover everything, and if you've watched them and read them and understand them, you will be doing it safely. This is a picture of 2 absolutely critical things you need before working on your project. The first is safety glasses so that you can protect your vision, and the second is a drawing so that you know what you are supposed to be or planning on doing. Without both of these, don't even think about starting. Now that we've seen the various parts of the drill press and how they interact with each other and all of the peripheral items needed to successfully use a drill press, drill bits, the drill chuck, the drill key, vices, clamps, etc. Let's take a look at a project that we will actually be using or doing, which is our MDF 4 task project. This is an engineering drawing of the project. It consists of basically using 4 different kinds of screw fasteners to attach the 2 pieces of wood to each other. And we're going to show you how to do each of them in a moment. This drawing shows the 4 holes that have to be drilled in both the top plate and the bottom plate. The first hole, number 1, is very simply the hole needed for a bolt to pass through the top plate and then through the bottom plate. So it is just a clearance hole for the 3/8" bolt that we'll be using. That size will be 25/64 in our experiment. The second hole is a bit different. In this case, we still have the same clearance hole that has to be drilled through the top plate, but we will not be drilling the same size hole through the bottom plate. The bottom plate has to be drilled and tapped for the 3/8" bolt, and that will eliminate the need for a nut on the bottom. So to repeat, we're going to be drilling a clearance hole through the top plate, and we're going to be drilling a hole for a 3/8" tap in the bottom plate. The third hole is for a 1/4" flathead screw to hold the 2 pieces of wood together. In this case, the hole drilled in the top board is going to be different from the hole drilled in the bottom board. In the top board, we're going to be drilling a clearance for the 1/4" bolt so that it can be pushed all the way through, actually 1/4" flathead screw. But it's also going to be countersunk at the top so that when the flathead screw is inserted in this hole, and I said inserted, it's not threaded in, when it's inserted in this hole, the head will be flush with the top board. The hole in the bottom board, however, is very different. It is going to be drilled and tapped for a 1/4 screw, which means we'll be using a number 7 drill and then a 1/4 tap to finish the job. The fourth hole is going to be using a 1/4" socket head cap screw or Allen screw to hold the 2 pieces together. This can be done in 2 fashions. It could be done the same way we did in hole 2, where the head of the screw is going to be on top of board 1 and it is screwed into a tapped hole in board 2, or it can be done as we did in hole 3, where the head of the cap screw is recessed flat so that it doesn't protrude through the surface. That is required for a lot of engineering designs. The bottom board in both cases is just going to be drilled and tapped for a 1/4 inch screw. 1/4 will be a number 7 drill. In this part of the video, we're going to drill the clearance holes for the 3/8 inch bolt that we would like to use to bolt these two items together. Now, clearance hole means that the bolt should fit nicely between the two pieces without having to fight the bolt to get it in the hole. It also allows for a slight amount of misalignment, which could be very desirable for whatever thing you're doing. All right, so let's take a look at the setup. We have, of course, our drill chuck, the proper size drill, which in this case we're going to make a 1/64 of an inch oversize, so it'll be 25/64. We have a drill press vise clamped to the table with the clamp. We've got this already previously lined up. We have the second piece over here we'll be doing in just a moment, and we're now going to be drilling both of those holes. We're going to drill the one here, take the piece out, and put the next one in to drill the second hole. All right, so let's go. We're about ready to start on the part. Notice that I don't have to hold the piece down because it's being held securely in the vise with a clamp on it. All right, that's the first hole and it is done. Now we're going to drill the second hole, or the first hole in the second piece. That's going to allow us to bolt the two pieces of wood together with a 3/8 inch bolt. Keep in mind the drill is slightly oversized so that we can have room for minor adjustments that we need when we're working in wood. Working in metal is a lot tighter, but working in wood not so much. All right, so here we go. We're going to drill our second hole again, and we're going to get a little bit better view of the drill doing what it does. And the hole is done. We're now ready to drill the hole for the second fastener that we're going to use. In this case, we want the 3/8 bolt to pass through the top piece without hindrance and screw into the bottom one. So in the top piece, we need a 3/8 clearance hole, which is going to be the same size as what we have here. So same size drills we have over here and here. However, the second hole on this piece is going to be for the tap that's going to be needed to do the 3/8/16 tap. Okay, that gives us our clearance hole for the 3/8/16 bolt we need in the top piece. We're now going to drill the bottom piece, the same hole center to center, but now smaller in diameter to accommodate tapping. Okay, we're now going to change the drill from 3/8 of an inch, or actually slightly bigger, it was 25/64, which was the clearance hole for the top board, to the hole we need to do the 3/8 tap here, which is 5/16 when you look at the tap and drill charts. So we take the drill out. Put it aside for a second. Spin it slightly to make sure we get it in the center of the chuck. Tighten it up. And now we're ready to put the part in the drill press vise. Just barely clears in the back, but that's okay. And we got to check one thing. Watch this. We put a slightly smaller drill in here and it's probably slightly shorter, which it is. So we're going to have to adjust the stop here to allow the quill to go down slightly further. Yeah, still a little more. Okay, we're good to go. Now, let's align the piece as a depth item here. We're going to slide it over. Almost make it touch. Clamp it down, and then I'm going to adjust it in and out so that we're in the right spot. Okay. That looks good. Okay, we've got the proper size drill in here for the tap. We're lined up in the center, close enough for what we need, and we're ready to drill. One thing I would like to mention, we use the clamp here to hold the vise down, and there's sometimes a little bit of a annoyance to clamp to the table because the bottom of the table is ribs. So you got to be careful and make sure you got the clamp grabbed properly someplace where it's not going to fall off. We're okay here. Alright, let's drill for the tap. Okay, we've got the nice size hole for the tap, and we're ready to start doing or lining up or setting up for the next hole. Alright, this is the bottom board, and the next two holes have to be drilled and tapped 1/4 20. So we're going to do that right now. To drill, we're going to actually we are going to drill and tap these for 1/4 20, which means we need to change the drill again to a number 7 drill in this case. So we got to take this one out. And we're going to put in the drill that will be correct for a 1/4 20 tap. We bring this down. Well, two things we're going to be doing now is one, making sure the drill goes down far enough, and two, we have to align it for the depth. We're okay on the center line because this is the way this is set up, but we still have to align it crossways. So let's see if we have enough of the drill protruding. We do not. So again, the stop has to be released a little bit more. Some machines have quick release stops here. Some machines don't have stops. And everything in between. The older machines don't usually have quick release taps, quick release dials like this. I mean, they don't have quick release dials. They have a dial like this. Okay, we got plenty of room for the drill to go through now. Let's line it up. Let's line it up for the proper position. Bring it over just a bit. Down. Now we have everything aligned properly, this way and this way. We've got the depth gun right. We can get through with the drill. We bring this up, turn it on, and we are drilling now for a tap for quarter 20. Number 7 drill. I'm going to flip it around so that I can get to the other side. Okay, I have the piece in the vise turned around. I flipped the end from end this way, and I've lined it up for the depth of cut. It's still on the center. So now we're going to be drilling it again for a tap for quarter 20. One thing I'd like to point out here is that the wood is coming up out of the hole. So the flutes on the drill are doing their job. They're taking the material out of the hole and getting it out of the way of the drill. If we were into steel, aluminum, or maybe even plastic of some kind, that becomes a problem because you want to make sure the material gets out of the hole. You got to clear the hole. In this case, the hole clears by itself, so we're good. Alright, the wood has been flipped around, replaced, and we're now ready to drill, as the drawing calls for, a 1/4 inch screw counterboard in here in the top part. Now, what that means is that the bolt itself has to be able to slide through all the way, but there's going to be a flat part at the bottom of the hole so the screw can sit and go all the way in. So we're going to have to drill it with a 1/4 inch drill first, and then we're going to use a regular 1/4 inch counterboard. We have the number 7 drill in here right now, so again, this has to come out. Almost made a mistake. This isn't the 1/4 inch drill bit. This was the clearance hole for the 1/4 inch screw. That's why you gotta, as they say, think twice, but act once. So what we're going to do is we're going to put this drill back, which is the clearance hole for 1/4 inch screw, and replace it with a straight 1/4 inch bit. Okay. I have a regular 1/4 inch bit here. Put that in. And I know from what we've been doing, we could easily go through the whole thing with this drill bit. It's 1/4 inch. It's checked, double checked, and that's what we need for a counterbore for a 1/4 inch screw. Okay, now to use a counterbore, a lot of it depends on the setup that you're doing, but since we have this setup already here, we're going to not take this piece out and disturb it. We're going to use the counterbore in the exact hole, exact same position. Nothing is going to be moved or changed except the drill is going to be exchanged for a counterboring tool. 1/4 inch drill comes out. Counterboring tool goes in. And gets tight. Now, when we use the counterboard, this is going to come in, it's going to slide into the hole like that, and is now going to come exactly 1/4 inch down, because that's the height of a socket head cap screw that's got to be completely enclosed. So we're going to put it down right here, and we're going to see another use of these things, the stop. We're going to bring the stop so that it allows us to just go a 1/4 inch or a tiny bit above a 1/4 inch depth. Okay, just a tiny bit more than a 1/4 inch, which adequately demonstrates what we have to do. Pull this out. I don't want it to start within the hole. All right, so now we're going to be able to come down with the counterbore. It's going to go up a 1/4 inch to that point, and we're ready to go. Okay, now we have the counterbore in the hole, and let's see if I have a 1/4. Yes, I do. So let me get a 1/4 inch Allen cap screw. Okay, here's our 1/4 inch Allen cap screw. It should drop into the hole, and the head here should be completely disappeared below the surface. And that's exactly what it does. So it is a perfect job. Disappeared altogether. Now this was a little tight going in. The reason it's a little tight going in is when you drill holes in wood, they typically don't drill holes exactly the diameter of the drill you're using. The wood fibers themselves bend a little bit. They don't shear off like it's a piece of steel. So after you drill it, it'll be just a little tiny bit tight. But that's okay. It's working fine here. All right, so now the next hole, what we have to do is drill it so that we can put a 1/4 inch flathead screw in here. Not a counterbore screw, not a cap screw, but a flathead screw. So first thing we do, take this out. And, all right, test time. What drill are we putting in? Number 7, 5/16, or 1/4 inch? The correct answer is 1/4 inch, because at this point we want the screw to slide through the hole, at least attempt to slide through the hole, and yep, there it is, 1/4 inch. We want it to slide through the hole, and then we'll make the flathead fit in there by using a countersink. Okay, we're getting this coming out good. Flathead screw for a 1/4 inch is about a 1/2 inch across here. So we're going to be using a countersink that will at least be able to make a 1/2 inch funnel-shaped hole or depression in the piece of wood. But for right now, we got to drill the hole. So, what do we got here? Doesn't go down far enough. Why doesn't it go down far enough? Because we were just counterboring it. One of the problems of machining is this got to go up and down. So, sometimes, if you have a machine like a Bridgeport, and Bridgeports are nice. You can buy a drill press at Home Depot, not a very good one, but you can buy one there for about $100 or so. But if you really have the money, you should get yourself an American-made Bridgeport. And this will be just a button, you push it and you pull it up. And it's a lot more things than that. Of course, the price isn't too good. I think the last time I looked at an American-made Bridgeport was about $18,000. So it's a little bit pricey. Okay, so you don't want it. All right, checking the height again. I'm looking here, and I'm looking here. We have plenty of room for it to go through. I just have to align it with the perpendicular line here. Stop this. And we're just going to move it this way just the tiniest bit more. I put a little dimple in the piece of wood so I could see where the drill was going, and I found out it was
on this side of the line that I wanted it to be on. But now it's going to be good. All right, so we drill a 1/4 inch hole. And now we're ready to counterbore so that this will fit in there. And again, this will be flush with the top of the wood. So these, the counterbore screw here, the counter sunk screw here, and the counterbore screw will both allow other equipment or parts of the machine or whatever you're doing, or just the plane not get you hung up, to slide across here. All right, so right now I need to take this out and put in a countersink, and let's do that. Okay, that comes out, and a countersink goes in. This is our countersink. That's the V-shaped hole that's going to make the V shape in here, because I didn't move anything, to match the screw. So let's put this in. Now we're really short, and we got to figure out something. All right, problem solved. What I had to do is loosen the table. The wrench is under here, the lock nut is under here. Wiggle it up in the air, which means I slid it back and forth a bit, and then locked it to about the right height. And then I put the drill back in and tested it to make sure it goes in and out of the hole comfortably. And that's good enough for woodworking. If it was metalworking, we would do something else. But for woodworking, flathead screw, no problems. All right, so now that I got the 1/4 inch screw back, 1/4 inch drill back in here to test it to make sure I'm in the center of everything, we now have to pull this back out again, and we'll put the countersink in again. But now we'll have enough room to get the countersink to make its hole the way it's supposed to. So now we come down with our countersink, and we got to have the circle that's created. Let's see how close I can get. Okay, we're going to be able to do a close-up of the counterbore making the hole, and the hole has to be a 1/2 inch in diameter or a little bit more, because that's what the screw is. So we're going to get my scale, turn this on, and we're going to let's see if it's long enough, or big enough, I should say. Maybe. Yep, it looks like it is. Let's test it out. Where's my flathead screw? Alright, problem solved. What I had to do is loosen the table. The wrench is under here, the lock nut is under here. Wiggle it up in the air, which means I slid it back and forth a bit, and then locked it to about the right height. And then I put the drill back in and tested it to make sure it goes in and out of the hole comfortably. And that's good enough for woodworking. If it was metalworking, we would do something else. But for woodworking, flathead screw, no problems. All right, so now that I got the 1/4 inch screw back, 1/4 inch drill back in here to test it to make sure I'm in the center of everything, we now have to pull this back out again, and we'll put the countersink in again. But now we'll have enough room to get the countersink to make its hole the way it's supposed to. Alright, so now we'll come down with our countersink, And we got to have the circle that's created. Let's see how close I can get. Okay, we're going to be able to do a close-up of the counterbore making the hole, and the hole has to be a 1/2 inch in diameter or a little bit more because that's what the screw is. So we're going to get my scale, turn this on, and we're going to let's see if it's long enough, or big enough, I should say. Maybe. Yep, it looks like it is. Let's test it out. Where's my flathead screw? Here it is. We're now ready to tap the piece of wood that needs the 3/8/16 hole. That's going to be here. We've clamped the piece of wood in a vise, and we've mounted the tap and the tap wrench. You can't hold all of these things at once, so that's why you need the vise. All right, now, when we put the tap in the hole and try and turn it around, we've got a tap that's your traditional tap. It is not a chip clearing tap. So we're going to have to go in 1 turn, back out a 1/4 turn. In 1 turn, back out a 1/4 turn. Well, in 1 turn would be this. Then back out a 1/4 turn. Actually, slightly more than a 1/4 turn. You want to get the chip to break it from the prior turn. So you're going to turn it in this way, and then you have to come back this way. But after you've done a full turn, you're going to back it out just a little tiny bit more than a 1/4 of a turn. Now, when you put the tap in, you must make sure that it's perpendicular in this direction as much as you can on the wood, and as much as you can make it perpendicular in this direction. So you're going to be winding up looking at it in 2 directions. You're going to look at it, you're going to be looking at it this way, and then after you get it this way, looking at it, oh yeah, that's nice and perpendicular. No, it's not. You have to put it in straight this way. It's not always going to be guesswork. And the projects we'll be doing, it can pretty much be guesswork. But there are better ways of doing it if exact perpendicularity requires it, and I'll show you some of them later. But right now, we're going to take our 3/8/16 tap, and we're going to run it through the hole. Keep in mind, we're going in 1 turn, and then backing out slightly more than a 1/4 of a turn. So we're going to put it in there, keep everything perpendicular as possible. This is my handle. I'm going to go in about 1 turn. And then I back out just slightly less than more than a turn. Okay, so now we're doing 1 more turn. And we back out just slightly more than 1 turn so that we can break the chips off in here. Now we're really not going to be breaking much in the way of chips here because we have kind of material, this kind of fiberboard, doesn't really create long stringy chips like metal would or even plastic. But we're going to do it anyway just as a practice. All right, so 1 more turn. And then back it out about 100 degrees. Another full turn, and then back it out again, about 100 degrees. Now, sometimes, depending on the material, you could do 3/4 of a turn. If it's really tough material, like a hard, obnoxious steel like stainless steel, or you might be able to do 2 turns. The big deal is to make sure that you have enough room in this groove, which is the flute of the tap, to absorb all of the chips. It's just like the flute on a drill. It has to be able to clear the chips. Okay, I can feel the difference. So we're able to go just quite a bit more. Now I'm going to back out. And we're going back in again. And we're probably breaking the chips up. Now keep in mind, this is not stringy chips. So what's happening is that as we're putting the tap in there, we're probably making a pile of chips on the bottom. And sure enough, we are. There's the chips. Okay, so that's why we're able to do more than one turn at a time. We could probably just go through, and I'm looking at it from the side, and sure enough, we're just piling chips up on the bottom. And that's okay. Actually, it's very handy right now. But remember, we're not going to be able to do this with metal. We'll show you the way to do it with metal later. Now this kind of tap is the one that would be used by mechanics and machinists that are into making stuff or repairing stuff where you are not necessarily able to go to the center of the hole, through the hole altogether. Okay, we've got our 3/4 inch, 3/8 inch 16 tap. Now let's just say, for instance, I have a big old piece of brass here, and I wanted to tap the end of this. Well, this is a case where the chaps cannot possibly fall through. Yeah, we can have it vertically, but there's no way for them to fall, so you're going to have to actually go down probably 3/4, out 1/4. Down 3/4, out another 1/4. All right, so that's what we have right here. That's our 3/8 16ths tap. We're now going to tap two holes that are 1/4 20, here and here. This one was for the flathead screw. This one was for the cap screw. So we're going to do that right now. And, well, okay, I'm back with my 1/4 20 tap. And again, we have the general purpose mechanics machinist tap. And this would be the kind of tap that you would be getting in most of your industrial supply houses if you don't specify something else. Because this kind of tap can go through, or it can be stopped at a particular point. So it's a more general purpose tap. Didn't say faster, but I said more general purpose. We put it in here. We tighten it up. And we do the same thing all over again that we did here. Keep it perpendicular, and we're going to be able to go down. Now, in this particular case, because we know it's the wood and it's got a lot of clearance, we should be able to screw it all the way through without any problems. Let's just see. I'm going to try and put my hand under it and see if I can hold on to the chips that are being generated. And I am getting some chips, but the tap 1/4 20 isn't making a lot of chips because it's a fine thread and it's fairly small diameter. Ooh, boy, tight there. All right. And I do have a little bit of chips in my hand underneath. When I get the tap out, I'll dump them on the top here, and we'll be able to, again, everything kind of be as perpendicular as possible. All right. That's 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Now we're really not breaking the chips because this is coming out as dust. What we're really doing is giving the chips or the dust a chance to flow out and come through the bottom or be pushed back into the hole in the opposite direction. So it's clearly, from my point of view, twisting this a much easier tapping job. And we're done here. I have my hand underneath it catching the chips again, or the sawdust that we're making through the threaded hole. anyway, that's the part of the tapping operation that we were looking at. Now, we should be able to, let's just clear this off, we should be able to screw the bolts into here. Now this was a 3/8/16 bolt, these were 1/4-20 bolts. We're just going to try it without bolting the second piece on. We're going to just see if the bolt fits. Alright, this is our 3/8/16 bolt. This is the hole it should go into. And it does do that very nicely. Now if we had an assembly, which is the second piece, we will be able to bolt the two things together. It goes through here, then in here, and then it goes all the way down. All right. Let me get a wrench. Good enough. And we got a wrench, and we can tighten bolts together, and it's actually quite good. It's a nice tight fit. All right. That's our 3/8 bolt. Now the next two holes that we had here and here are 1/4-20. This hole, I'll take it off so you can see it. Unscrew this so that you can see it. Okay, this hole here is the flathead. This hole here is the counterbore. So for this, we need the flathead screw, which is here. Okay, there's our flathead screw. There's where it goes in here. This is kind of on a long slide, but that's okay. And now we're going to put the screw in the hole. Get our screwdriver. This is a slotted screw, so we use a slotted screwdriver. In fact, this is a ridiculously long screw for the job, but it happened to be the only one I have hanging around. But you can see that it is going to work. And that's working just fine. I think I actually have 1/4-20 screws that are socket head cap screws, socket head flathead screws, which means an Allen wrench. So let's just take a look at that for a second. Okay. Yep, got one right here. Actually, just about the perfect length. So, all right, so that one goes through. That one goes in here. Let me get an Allen wrench. Allen wrench is the classic name for this because they're the company that originally designed this type of a screw or a driving mechanism, and we just pull that on down. And again, we got a nice tight fit. Okay, so now the last one, let me remove this one so you can see what it looks like. Taking this out again. Socket head screws or Allen screws are really nice to work with because they're generally very, very high grade steel. I use nice to work with because not only is it a high grade steel, but the socket, the wrench fits in the socket so nicely you can do that. You're not going to be able to do that with a traditional screwdriver. That's just not going to work. But it does work very nicely on here. And depending on the position that you're in, if it's under, or your mechanic is in, if he's under a machine or something like that, it's a lot easier to use this kind of a screw. All right, so we have that one in there. Now we're going to get a different socket head screw, this one here, and it's a slightly different size. This one's a little bit bigger. So we'll get a little bigger wrench. We have a little bit bigger wrench. And we're going to put that through the hole. Okay. And this goes in here. And again, we're taking advantage of the self-assembly property of a socket head screw to push them together. And we got that done. That's nice and tight too. Alright, so we got them all done. It's unlikely that we were able to line up all of these. Oh, the last one, of course, was the 3/8 bolt in the end, which would require a nut on the other side, but I don't think I have a 3/8 bolt long enough for that, or I have 3/8 bolts that are too long for that. Maybe. Oh yeah, there we go. Nice to have a lot of stuff hanging around your shop. Alright, so we would just be able to put a nut on the bottom of this and tighten the whole thing all up, and we would have that together also. Alright, so
this is a typical machinist or mechanic's tap and die set. The items that are straight are taps, the round ones are dies, and there are also tap wrenches, 2 of them, and a die wrench in there, along with a screwdriver for operating properly the die wrench. These are the 2 most common types of taps. The tap on the left is a general purpose tap, and the tap on the right is a self-clearing tap. You can see that the tap on the right has a bit of an additional grinding on the bottom. Before that grinding occurs, both taps are basically identical, but that grinding makes it a self-clearing tap of the chips. This picture shows you a view of the general purpose tap's cutting edge on the left, which is a straight line, and the self-clearing tap's cutting edge, which starts off as a curved line and then goes straight. Both taps are initially the same, except that the self-clearing tap has an additional grinding portion. This is a picture of the crumbly type of chips that are coming from the general purpose taps, as opposed to the self-clearing taps, which you'll see next. This is an example of the long stringy chips that come out of a self-clearing tap. They come out of the bottom of the holes, so this type of tap cannot be used in what's called a blind hole. It has to be a hole that goes completely through the material in order to be able to use this. There are tricks for using it in another fashion, but that's beyond the purpose of this video. I hope you enjoyed this video on use of the drill press and taps. Have a nice day.